So today we will discuss about uh, port scaling. Okay, I mean how we will auto scaling our resources inside Kubernetes. We called as horizontal port auto scaled. Okay. So before that, I am quickly launching the EKS. Okay, so here you can see uh, I am going to, installing EKS. Okay. Okay, so coming to topic. So, anyone know what is horizontal port autoscaler? All of you.
No idea, sir.
Okay. What is or horizontal port auto scaler?
Are you showing your paint screen
Yes.
so we can see, sir?
Now it's visible, right?
Yes, sir.
So basically, horizontal port we called as HPA. Okay. HPA. So HPA stands for horizontal port autoscaler. Okay. So coming to Kubernetes. Okay. Coming to Kubernetes. Kubernetes resource just used to automatically scale the number of pod replicas in a deployment or replica set based on observed metrics such as CPU utilization or memory usage or even custom metrics as well. Okay. So horizontal pod scaler adjusts the number of pods in a deployment based on certain condition or thresholds, allowing the application to scale dynamically based on demands. For example, we deployed an application. Okay, that application have two containers, container one and container two. So this is default state. Okay, a desired state for running the application. For example, in case there is more load or more request to our application, okay, inside the container we deploy our application. Okay, so whenever the application usage, okay, exceeding some usage in the sense of like CPU utilization is high or memory utilization is high, okay, similar condition, we can scale our application containers, right, or application pod. So in this case, coming to Kubernetes, we use a resource called horizontal pod autoscaler to scaling up our container. So we can set up that inside Kubernetes and we can uh, define like our current state. Our desired state is two container. So whenever the load high, we can add more container. Like we can set up how much container creating. Okay, whenever the load happen. So it's like two. The current state is 2 and we can set up that desired state like 5 or 10 like that. So whenever the whenever the usage is high, the Kubernetes automatically creating container for us, also the application. So the application is high available and it's balancing our application health. So in this case we have two desired one. This is a desired. This is container 1 and container 2. Okay, container 2. So in this case, our application replica is 2. So whenever load increase, it will create 5 more containers or 10 more containers. So what we provided in the configuration. So it will create container 3, 4, and 5. Also, coming to Kubernetes, actually it's creating pod, okay? Like pod 1, pod 2 is a desired one, and 3, 4, and 5 will create as per the usage. So the load is high, and we created 5 more containers. So, okay, I mean Kubernetes created 5 more containers. So when the load goes down, what will happen? It will remove the container and go back to the desired state, like two that we define in the configuration, like YAML file. So that we can define the minimum replicas. Okay, minimum replicas is two, and the maximum replicas is five. So that we need to define in the YAML file. So the scaling, I mean the auto scaling, adjusting the number of replicas of pod rather than changing the resource allocated to each individual pod. Okay, like which would be uh, in like this is actually a case of horizontal pod scaling. Okay, I mean horizontal scaling, horizontal. Also, vertical pod autoscaler are there. Okay. Coming to vertical, this what are things that we do? Like just allocating more resources to individual pod. Okay, like coming to the individual pod has like some millicore of CPU and memory we allocate. Okay, so we can adjust that resources as well if we use vertical pod autoscale. But most probably we use horizontal scaling. So it will multiply our instance of applications. So we can ensure that our application can handle varying load and demand without manual intervention. Got it, all of you? Anyone have any doubt? All of you?
Yes, sir. Got it.
Yeah. Yeah, it's Mukesh, right?
Yeah, it's like I got it, Tawfiq.
Okay, okay. So that I'm going to create a cluster. Okay, so we'll show you how to load balancing. Okay, I mean, sorry, not load balancing, how to auto scaling our deployed resources. So in this lab, we will deploy a sample application, then we will try to load, generate to the specific or particular pod, application pod. So the application pod will, sorry, the Kubernetes will creating multiple instances of our application pod.
Tawfiq, Mahesh here.
Yes.
When there is a more traffic to the application, usually load will get increased. So when the load is get increased, it automatically when we configure the HPA, the another cluster will get creation, right? Another
Not
three more
cluster.
cluster will get created.
No, 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 no.
Sorry,
This is not
a container.
right, right.
Sorry.
Pod.
Sorry, I missed. Yeah. Container pod will get create automatically, and it will
Yeah.
adjust to the application, which will run smoothly. Is that the correct process, right?
Right.
Okay.
So we called as horizontal pod autoscaler Kubernetes
Yeah.
for the same.
Yeah. Usually, this will taken care by the DevOps team or network team.
No, DevOps. This is actually autoscaling, actually. Setting a autoscaling in our resources. Coming to the machine, okay, like this is for Kubernetes. If we are using normal EC2 machine, we can set up the same in
AKS,
AWS.
AWS.
No,
Okay.
AWS. There is an autoscaler option there. So we need to set up that configuration. I mean, how the load heating, what triggering, like the CPU utilization or memory utilization, everything we can define in that configuration. Because whenever there is more load heating, what will happen? Our
Obviously, application
machine,
will go slow.
uh, yes, but actually, what will happen in our machine? Like the CPU and memory utilization. Sorry, first it's hitting memory utilization. Okay, sorry, CPU utilization.
Correct.
CPU utilization is
Correct.
going high because n numbers of incoming requests are hitting our machines. So that machine can't manage all the requests, right?
Yes.
So the utilization is high, going high. If the CPU utilization high, memory also going high. So both are
Correct.
utilizing more resources in that case. So we need to add more same machines to handle those requests. So we need to auto scale even in VM case or Kubernetes case. So coming to Kubernetes have native resource like autoscaler, like horizontal pod autoscaler. So we are going
Okay.
to utilize that in
Is
this lab.
this this process is a part of Kubernetes deployment strategy? Because in
Yes.
deployment strategy, we will put the memory into 250 MI or 500 MI based on the future requirement of the application. That is the memory
Hmm.
part, correct?
Right.
So here, when the memory is affecting due to the huge traffic, automatically, if you adopt the HPA, one more container is going to get create.
Right.
It,
And balancing the application.
it will balance the application.
Yes. Availability. So my cluster is deployed. I mean running fine. kubectl. Okay. So first we need to deploy a sample application. I will get one from GitHub. So I have an existing repository, okay, for the application deployment. So I'm just cloning this from my repo to my machine. By default, Git is not installed in this machine, so we need to install Git first. Now I am downloaded successfully. CD. Right. So my files belongs to HP, okay? That Kubernetes files. I'm going to 05. Okay, see here. For the deployment, okay, like horizontal pod autoscaler, it's a resources. Okay, so we need to create a separate YAML file for HPA and define everything based on the application. I will show you what are the content under the deployment. So this is our basic application, okay? So see, it's starting from version, then kind is deployment, metadata, the name of that deployment, that is HPA demo application or demo deployment. This is for a demonstration of how HPA works. Okay, that's why use the name HPA demo deployment. Here you can see the desired container state is one. That means whenever we deploy this, I mean applying this YAML file, it will create a one pod with one container. Then the label same HPA demo deployment. And image, see for the application image, this is a simple image from Kubernetes GCR and this is a username and this is a image name, example HPA. Then port 80. And coming to the resource, you can see here like how much that we allocated resources for this specific application. 500 milli CPU and request. That is, this is only if we mentioned the CPU, okay, not memory. So the max request is 200 milli and the CPU limit is 500 MB. Okay. So this is the service for the same. It's nothing actually. We define, I mean, we selecting the above deployment as our service selector. Okay. Here you can see the selector HPA depot deployment. So this is connected to the above deployment. Then HPA as well. Cat 03 HPA dot YAML. So this is a horizontal port scale and configuration. See, so here you can see the API version, that is Autoscaler v1 kind. This is, I told you, this is a resource in Kubernetes. That is, we mentioned the kind as the resource type that we use in Kubernetes. That is horizontal port autoscaler. So the Kubernetes know This is for the horizontal pod autoscaler. Then metadata. So metadata we provided that same application label. Okay. HBA demo deployment spec. Yeah. This is for the horizontal pod autoscaler name, and under the spec we define which deployment that or which application deployment that this specific autoscaler is connected. Okay. So here you can see the name under the name HBA deployment there. Kind is deployment. That means we have a deployment source type is deployment there running, and the name of the deployment is HPA demo deployment. So this is connecting with our uh, deployment that is named HPA demo deployment. So the minimum replicas that we use for that application is 1. So maximum is 10. So it will create 9 more container when the target CPU utilization percentage is above 50 percentage. Got it?
Sir, can we
Oh,
change the maximum replica?
yes, we can change. Like I'm just editing 10 to, I mean just decrease, okay, to 5.
So is there any sequence or we can pick any random number or depending upon our need?
Any random number as per the requirement only, okay. Nano. So I'm changing to 5. Got it. So I'm going to deploy one by one, okay. First I'm going to run kubectl, apply -f for the file, then the file name. See, now we have only one code, okay. Still it's creating the container creation state. So it will take a couple of seconds. After that, it will status going to success. See, now it's running. So the next thing is we need to deploy service. So I now created the service as well. So I'm checking kubectl get deployment. So it will show all the necessary thing under the deployment. Okay. So deployment is one is ready and dash in. So get SVC for SVC. See, our This is our deployment service that we created. And its type is cluster IP. Okay, that's why we didn't get anything like external IP or anything. Still, it's we didn't use this application externally. We only use this as a sample application to testing. I mean, generating load. Okay, so whenever we automatically, oh, sorry, manually generating load to the container, and the container utilization going high above 50, then it will create that auto port scaler will create that this, I mean, the container that we define in the configuration. Got it. All of you.
Yes, sir.
Okay. So now I am going to install HPA. I mean, apply. So kubectl apply -f, then the name of the deployment YAML file. Because missing reflected maximum application Kubernetes. This. Okay, here you can see we didn't save that maximum replicas. See, it's nothing there. It's 5, right? 7 exit. Now it's fine. Now I'm going to reapply again. Okay. Yeah. Horizontal port autoscaler created. kubectl. We can use kubectl top command. Okay. Top command is using for uh, knowing that specific content or port, how much utilization they taken. Okay. So kubectl get port. That command is kubectl top, not top port. Okay. So here metrics API is not available. So we need to install metrics API. Okay. Without that, it will not show anything. This is the command to install that. So I successfully install the metric server. Okay. So the metric server means it's a specific service for getting the details of Kubernetes application or Kubernetes container resource utilization. Okay. I mean, how much we can see that whenever we typing the top command, this is top command. So it will show each application or each container or each port taking how much resources. Okay. So I'm just run the command again. See here we can see as of now we have one deployment, that is demo deployment, and the CPU it taking like only 1 milli, and memory is 9. I think we have set up that request, request and limits for the specific YAML file, that is 500, right? Sorry, 200 is a uh, limit. Sorry, requested
Yes,
you for
250,
this specific content. Yeah, and the maximum is 500.
500.
But now you can see it's taking only 1 milli.
Correct.
There is nothing happening to that specific container.
Okay. Is it showing that the usage of memory or available memory or something?
Sorry.
That CPU is showing now one memory, right? 1 M and 9 MI.
Yeah,
That's
it's
supposed to
a
show
milli,
250 and
milli, only milli. Out
only
of,
milli,
I
right?
think, 200, right?
250
Out of,
or something.
yeah, out of 200, it will take only 1 milli CPU core.
Okay.
So next thing is we need to, in this case, we can't do anything because we need to automatically generate, sorry, manually generate some loads to the container HPA demo deployment. So there, for that we need to use a generator content, for I mean inside this same Kubernetes. Okay, here also we can see when using HPA, kubectl gauge HPA or report autoscaler, the name of the HPA and everything we can see here. And here you can see target CPU utilization. CPU now it's only 0%. Our trigger state is 50%. Okay, like whenever the CPU met that 50 here, it will create port, right? Maximum is 5, minimum 1. For that, I'm going to create one more terminal, duplicate. Okay, fine. So this will be my second window, for the same. Because I'm using a generator command here. Then let's, kubectl. Okay, fine. So now I'm going to run one more command to create a generator pod, kubectl run -i. PC box is a image name, that is available in Docker Hub. That is actually a image to generate load, Okay, some error happening. I will try one more, okay, like kubectl command. Can't open index.file. Yes. Now it's fine. Okay. All are following me, right? See, now it's load generated. So now we can check here using HPA. As of now, it's 0%. See, now it's 43%. Okay. I'm checking the kubectl get pod. See, total pod, how many pod we have? So now it's you can see the desired state is we exceeded that 50%. Now it's 150. So I'm checking the pod count. See, total 5 pod. I mean, our maximum, we met the maximum replicas. That is why. Got it. So that's our maximum. No more than 5. Got it, all of you.
So what will happen if it increase more than 5? Like it will not come here, but if the traffic increases, then
Then we
the
need
load,
to,
yeah,
yeah, we need to scale more. Like go to the open the HPA and we need to,
YAML,
yes, yes, same YAML file.
okay, and max limit we need to set.
Right. That we need to calculate. Like for example, if we deploy an application, right? So actually, better to keep like 1 to 5 is fine actually. So if you set up more than 5, that is enough for the application. Also here we can see the utilization for that specific. Now it's back like before you can see it's 150, the maximum that load is generated for the specific application. Got it, all of you. Any doubt? All of you?
Sir, how you are increasing the load here?
Manually using see now it's this is attempting to create a request to the running container. Okay, so in this case I created a load generator container here. See, sorry, one pod here. So this pod actually manually generate load to our HPA container. So the load increase above 50, it will create
But
multiple instances.
how this load generator is getting requests from the other one, other machine?
See, this is a command to create the load generator. So in that command, we defined where it is like here. Here I used a command to show you. This is a command. So
Hmm.
this is a command to like run a container. Okay, run a container, load generator container. That's the name. And here I use the image for that container, that is busy box, and restart and everything is sleep. Then this is the path. I mean, now we created a container. Sorry, we created a pod with the name load generator and the image is busy box. We need to specify which is our application to put generate. So this is the deployment URL.
Hmm.
See, HPA, HTTP, HPA demo
Hmm.
deployment. So these containers know I need to generate load to the HPA demo deployment.
How it is changing, like every time the load percentage is changing, na? So how that thing is managing?
That thing means the
The
HPA
percentage
deployment,
of
right?
a load. Yeah, the percentage of a load is accordingly, then we are it is scaling up the
Here
containers
what?
are.
Yeah, here what will happen? This busybox container, okay, or busybox pod generate multiple requests to this container or this deployment. Okay, in our case, we have a deployment like HPA demo, and we have a pod, right? So
Hmm.
this container will attempt, I mean, sending multiple requests. So our container utilization is high. So the container will create, or the deployment will create more containers here to
Yeah,
balancing.
so
Now this request to sending to the multiple instance of our application. So the one is hitting our first container, second is hitting second one, like that. It's balancing. Kubernetes will automatically balance it.
no, I got it. I got that point. I just need to know how. Okay, so first time only the four ports open. Then the second time when the load increases, it increased to the five ports, right?
Yes.
So how this percentage is of a load is you are setting, like that's what I need to know. Automatically it is scaling up the pods, that I understand. But
Hmm.
how the load you are increasing? Or is it like doing automatically it is increasing? Like here you can see 60%, 50%, then
This one, right?
59. Yes. Yes.
Yeah. That's actually this this one. Okay, the load generator
Huh. So how
will
this
managing that things. Here you can see
it is
um,
happening automatically, sir,
by
by
automatically
using this
by
command.
the container.
Okay.
Yes. Now it's a time period actually. Set up a time period for hitting the load generation. So now you can see it's below. Yeah, it's decreasing. Uh, First time when we running the container, it will generate a lot of requests to the specific
Yeah. So
port.
how did you decrease it?
Now it's decreasing.
Yeah. How did you do that? What you did?
It's automatically. We didn't do anything. It's
Oh,
automatically
okay.
managed by the load generator.
Okay.
This is
Okay.
just for generating the request. Okay, so that's why we manually run a specific port to generate that request. In real world
Okay.
scenario, a real user request will be the
The
same.
load generator would not be there. It would be like the real traffic, like load
Real,
generator, but for the real traffic, right?
right. Yes.
Okay. And our part, what we need to understand from this train, like this today's session is like how we have scaled it
How to set
in
up a
the
auto?
YAML file. Like we
Yes.
have set the count for limits, like for the
Right.
max and minimum. And then using the HPA commands, we are checking like how it is, in scaling up or down accordingly to the
Right.
traffic.
Right.
Okay. Okay.
I put that repository URL, okay, in the chat. Hope you all the commands to run Kubernetes, right? Then after building the Kubernetes, you can run the command git clone. Then you can clone the repository and try to do the same lab, okay? Also, I will put that generator command as well here. Okay. All of you please copy, okay, this one. The putty generator. Got it. All are copied, right? From the chat. Pooja, Mahesh.
I'm copying.
Okay, the repository name and that container creation name. Okay, the load container. Rest of them are same. No issue. The rest of them, we can clone it from the repository. Any doubt? All of you?
Sir, can you send it like the way you sent it to us last time? Don't do the installation commands for Kubernetes that we already have, but what we did after that, like three, four commands which we used.
I will share. I will share. I will share.
No, because like this is the final command, I
Yes.
understand, but there are
Yes.
few more command goes in between after installation and this
Mhm.
command. So I don't want to miss the sequence and mess up the thing. So it
Yeah.
would be great if you
I will
can
share.
share.
I will share. I will share.
Yeah, thank you, sir.
Yeah. Then we can wind up, right? All of you.
Yes. So yeah, let me see.
Yeah. Then by all, we'll meet tomorrow. Okay. Bye bye.
Yeah, bye, sir. Thank you.